So here we have an outline. IEEE unsanctioned competition was on. Talk about like what the robots are. Talk about, let's see.
Excellent.
How do I? There we go.
There you go.
So we have the schedule here today. I'm not sure. Do we have a specific date?
No, we don't
coming
have
up?
dates yet.
We do have for the second. The second date is next Friday,
Next Friday.
but the last two we're still deciding.
Okay. So next one is next Friday. Competition. So here are the rules. It's going to be a round robin tournament. It means everyone is going to end up competing against someone else, every other person in the tournament. And you have 5 minutes. We can work that one out, but for now we have 5 minutes to try and pop 3 other opponent balloons. So on the opposite robot, and both robots are going to have 3 balloons. And the idea is with the weapon that you're going to design, you're trying to pop them and score points. So there's going to be 1 weapon per team, no projectiles, because we don't have a cage or somewhere enclosed to fight, so we don't want anyone getting hurt. 3 balloons on each robot, and it is going to be a tournament style, but it's round robin style. Scoring wise, 10 points per balloon each round. So you have up to 30 points that you can win each round. And then we're just throwing in 10 points for aesthetics, because when it comes to design, you want it to be somewhat nice. The major components of the bot are the Pico. It's a Pico W, which means it connects to Wi-Fi, but we have a separate module for Bluetooth right here to connect to a device so you can control it. We're gonna have 2 18650 batteries, and there's the motor controller, which we're probably gonna have 2 of, one to control both wheels, and then the other one to control the weapon. And then 3D printing. I'll talk about that.
Can you turn the camera?
Which way?
This one.
You can't really see.
You can move it up.
No, like it's so dark.
Yeah, they can see that.
You can't really see it. I wouldn't worry about it, Jonathan. Just
Okay. Okay, whatever. So for 3D printing, the main steps for 3D printing is to, 1, make your 3D model, which is what we're going to be going over the basics of today. After you make your 3D model, you will export it as an STL file. This file can be sliced by 3D printing software like Cura. It cuts it up into many tiny layers, and then your 3D printer will melt all those layers together, and it will eventually form your end product. Whenever you are importing it into whatever 3D, I just pressed the button. Did it turn off?
no.
Okay, cool. Whenever you take it into your 3D printing software, you want to make sure that your use case is able to match the orientation you're printing it, amount of infill you're printing it. So if there's a lot of stress on the part that you're printing, you're going to want a stronger infill and a more dense infill. And then for the orientation, whenever you're 3D printing, the layers are weakest how they're printed. So you want the weakest part of the print facing up, like the part that doesn't go under the most strain. Next slide. So for installing Fusion 360, do we have anyone in the chat?
We do. 3 people.
Yeah, but did someone say something?
No.
Okay, cool. For the Fusion 360 installation, you can make an Autodesk account with your UH email. You can also do this with your personal email. It doesn't matter. You will just have to make sure to download it as a student. So it'll either say on Autodesk that you want to download as a student or download for personal use. It's one of the two. There's a bunch of other softwares that are on there that are free. There's a 3D animation software. There's a 2D CAD software. There's Inventor, which is another 3D software. And yeah, I encourage you all to check those out if you want to. There's Revit if you guys like civil engineering. So yeah, once you download it and install it, you can sign in to your account in the app, and you will be asked to set up a team. You can make that name whatever you want, and then it will let you into the app. All that is so that way you can collaborate with other people online. Any questions? Alrighty, next slide. Do you have any questions? Okay, cool. So to start, you can click Start 2D Sketch on the top left of your screen. You see that? There you go. It will come up with the planes. These are the XY plane, the XZ plane, and the YZ plane. This is the default orientation of your thing. So if you feel like the easiest part of the model to do is like the bottom part, then you will start on the bottom plane. And then if you want to do it from a side view, you can do that as well. This is just to make it to where your orientation, you're able to like view it easily by pressing the home button. You have a view cube in the top right. That view cube, you can click on it and it'll rotate around the screen. So you can click on like the corner and it'll automatically go to the corner. You can click on a face and it'll automatically snap to a face. There is one thing to note, that for the view cube, the default for this app is that there is no perspective. So there's no vanishing points off in the distance. If you look at something from top down, the lines go straight down instead of vanishing. So there is that. So you can choose any of the orientations here. And then we can continue on to the next slide. So we are going to start by clicking the circle button on the top left. And then clicking on the origin. Make sure to click the top of the cube or whichever orientation, so that way you're able to do your sketch. Press escape and then click the cube and then do it again. So after you click the circle button and start drawing your circle, you can type in a number. The default for Autodesk, I believe, is in millimeters. So if you type 28 millimeters, it will snap the circle to 28 millimeters. After you press enter, it will make the circle an actual shape on your screen. You can double click the diameter of the circle that has the number on it, and it will bring up a little text box. There you can change the specifications of that shape. You can do this with any shape as long as it is not constrained to another shape or like another dimension. So after you press 28, go ahead and double click on the diameter. And then type in 22 millimeters. Next slide. Now you can make another circle inside of that circle. Sorry, on the outside of that circle with a diameter of 40 millimeters. This will become the outer portion of the body of that section. You can type in 40, or you can have it lock onto the grid. And next, you will click rectangle on the top left of your screen. And then you will draw it out to be 200 millimeters by 40 millimeters, starting at the top of the diameter of the circle and going to the bottom of the diameter of the circle. To switch between the dimensions of a shape, you type in a number for the first one that is highlighted, and then you can press tab and it will switch you to the second portion. After you press enter for that, you can click on whichever dimension you want to change, and it will change that specific dimension. Any questions so far? All right. Once you have sketched the rectangle, you can click the scissors button in the top left. This is the trim button. This function is basically just used to make it easier and faster to extrude objects, so you don't have to extrude multiple objects at the same time. It becomes one large object. For the trim button, you will click the leftmost side of the outer diameter, like the larger diameter circle, and you click the right side of the rectangle. It will delete those portions, and then it will merge the other portions of the other shapes where they intersect. Oh, also you can zoom in with pinching. So zoom in. Other way. So you're going to cut this one, this one, this one. So you have trim clicker. You have to click on the shape. So highlight it in purple. Click on it, gone. Highlight it in, so that one's already done. Highlight in purple, click, gone, and you can do the last one. Then you're done. From here, we have the basics for our first model. You can click Finish Sketch. Next slide. Oh, next slide. And then you can click Extrude. When extruding, you're allowed to extrude in one direction for the most part. I believe there's a shear extrude as well function. So it allows you to extrude to the side at an angle. But here, you will just be extruding vertically. Extrude the sketch by 8 millimeters, and then you can make a new file with the hotkey Control N. Do make sure to save this file before doing that though. So press Control N for the new file. All good, next slide. Now we will be making the same shape, but this time it will have 2 circular ends instead of just one. So do the same thing. To start off the shape, start a new sketch, select your plane, graph a 40 millimeter circle at the origin, graph a 40 by 200 millimeter rectangle, starting at the top of that diameter and to the bottom of that diameter. Then on the opposite side of the rectangle, graph another 40 millimeter diameter circle. Once you're done with this, we are going to be making room on the right side of the model for an axle. We will be doing this by selecting the center rectangle button. There is a drop-down menu under the create ribbon. You will select rectangle, and then you will select center rectangle. This makes it easier and faster to be able to plot rectangles that you need to be the center of. Otherwise, you would have to draw 2 lines to be able to get the offset of the first corner. From there, you will make a 3mm by 3mm square at the other corner. And then that'll be it for this slide. Oh, and make sure to trim all the edges of the circle as well. All right, that's all good. You did it, right?
The center circle.
He just needs it. It's not a circle, it's a square.
Oh, the square.
So click the create ribbon, move down a little bit. It's that, create. And then click rectangle, click center rectangle. And then click on where you want it. You want it on one of the dots. Scroll in. Oh, there you go. So make it 3mm by 3mm. And then you're done. Next slide. So here we'll be extruding by 8mm again. This will be the lower portion of the arm as a basic design. As I said earlier, the square pole is for the axles that we have. And then on the other side, we're going to be making a 7mm peg. This will be going inside of a ball bearing that will be inserted in the first object that we created. To make this peg, we are going to be making a sketch on top of the face of this object. Make sure you extrude. Finish sketch, extrude. So to do that, you will just be selecting Start 2D Sketch and then select the face that you wish to write on. You can still lock on to the other points that you have made. So we'll be making a 8mm circle on the whichever side you didn't make the square hole on. You will make a 8mm circle there and extrude it by 7mm. Okay. Is there any questions? All right, so next slide. Now we are done with both of our files. Once you have saved your file is now stored in your memory and you can access it to be able to convert it. You can go up to the top, click File, click Export, scroll down for the file type and click STL file. This is the file that we're going to be slicing into G-code. All G-code is a list of commands that go into a 3D printer. They tell the motors on the 3D printer which ways they need to be turning so that way they can get to a certain point on a grid that is inside the 3D printer's like printing bay. STL will be near the bottom. I believe for Autodesk, you will need to be connected to the internet to do this, but for heavier programs, you will not be. They will have a converter in the app. And we can go on to the next slide. And that's it. Back to Alejandro or Austin.
Well, I'm gonna pass it to Austin.
All right, so we have a couple ideas for the possible designs for the robot. Mostly just the weapons. So we have an idea for attack hammer arm, which would be represented with the one on, it's like the orange robot. And then we have a saw blade idea, and then a chomper idea, which will bite into a balloon. We'll be 3D printing all of these weapons, and then we'll fit them onto either a stepper motor or a servo motor. And yeah, do you have anything else to say for that?
All right, we can turn on the light. I'll show off this prototype that we have here.
Camera. The actual. I have a spotlight. I'm saying. So.
All right, turn on your camera. It's connected to this computer.
No, his is on.
Oh.
It's weird on this one. Are you supposed to? Yeah.
There we go. Can you hear me? Okay, so this is the prototype. It's definitely looking a little rough, but these are the batteries. Later on, they're going to be a full pack. Here we have the Bluetooth module, the Pico, the motor driver, the motor controller, and here are the motors. Right now, we just have this simple app that we made to control it. You can see it here. Some functions aren't working, such as reverse, but this is just a test for right now. And it gets stuck on one function going forward or going right. But the idea is simply that this is the platform. Once it looks obviously nice and pretty, less wires and everything, you'll just have this platform on the bottom. And then on top of it, you can build pretty much anything you can come up with, right? Any rotary weapon or something that goes up and down. And yeah, this is the prototype. We're hoping to use Bluetooth. So it'll just be standard. We'll probably have 2 devices where you can control. And then you just connect to the Bluetooth module of your specific robot, and then we can control it from a tablet or a phone. Yeah, it has to be Android. So we'll have 2 devices that they can control it from. But yeah, this is the prototype. It'll probably just be in the lounge, so if anyone wants to come by and see it, and also if you have any questions. Yeah, so the idea was really to introduce everything now so that everyone kind of understands like we're using Fusion or whichever 3D modeling software you want. But this is the general outline, and you guys can start working on it now, designing any part and asking us questions from now till next time. And then by next time we should have everything done so we can give them, right? Or they can have each team can have their platform to use. Yeah, no questions. And you're IEEE president. Crazy. Have any questions? Any ideas? No ideas on which weapon you want?
On that, you still got about 15 minutes. Thanks for coming, everyone. We are going to be helping people in person build at the moment. So if you guys need to come by the lounge.
I'd like to thank our sponsor, Matt. He made all this possible.
Thank you. If you guys need to come by the lounge and get your parts, it's fine. We're trying to keep this both virtual and personal, but if you're welcome to come by and come anytime you like. We're gonna try to shoot for next week, at least getting in person so we can build the robots. You're welcome to come on by and help put that together so we can meet you as well. But don't be shy. We'll be here for you. And if you guys need anything else, just don't hesitate to reach out. All right. We'll see you guys later. Thanks for joining.